Welcome to the next lesson on concentration of a solution. In this lesson, we're going to be talking about solution concentration measured with moles per litre and the reference to grams per litre as well as mass per mass, mass per volume and volume per volume in parts per million, and how this is relevant to domestic and commercial applications. So concentration describes the relative or the amount of solute in a given solution. So here a dilute solution does not have much solute, a low amount of solute in a particular solution. Concentrated, you're increasing the amount of solute, and then saturated is where you have a maximum amount of solute present in that solution. So dilute shows a small amount of solute in a large amount of solvent, and concentrated shows a large amount of solute in a small amount of solvent. Concentration is usually measured in grams per litre, -1. So this indicates the mass in grams of solute dissolved in 1 litre of solution. So for example, if we have 20 grams per litre, this means in 1 litre of seawater we have 20 grams of sodium chloride. Let's take another example here. Concentration is given by mass of solute in grams divided by volume in litres. So the concentration in grams per litre of 8 grams of sodium chloride in 500 ml of solution is calculated as follows. Well, first of all, we need to convert the 500 ml into a litre, because the volume is always reported in litres. So clearly here you've divided 500 by 1,000, converting mils to litres, so we have half a litre there. The concentration is equal to the mass of the solute, as you can see up here, divided by the volume in solution. So we have 8 grams divided by 0.5, which means we have 16 grams per litre concentration. Now we're going to talk about concentration in terms of parts per million. So when there's very few quantities of solute dissolved in a solution, that concentration is reported in parts per million. So we may be measuring the mercury levels inside, say, waterways, and those levels are very small or very low. So we're actually looking at parts of, say, 1 gram of sodium chloride per 1 million grams of solution. Or we've got milligrams, 1 milligram dissolved in 1 kilo. So that is 1/1,000,000th. So a millionth here you can see, there's a particular cube, that's a thousandth there, that's a millionth. So we're looking at 1 part per million. It's a very small number. So to calculate 1 part per million, we can use the following. Concentration in parts per million is equal to mass of the solute in milligrams divided by kilograms, because a milligram is 1/1000th of a gram, and a gram is 1/1000th of a kilogram. So therefore, a milligram is 1/1,000,000th of a kilogram. So if we were looking at a saturated solution of calcium carbonate, it has 0.0198 grams of calcium carbonate in 2,000 grams of solution. We're going to calculate this in parts per million. So what we need to do is we convert the grams into milligrams, because that's our 1 part per million, which equals 19.8 milligrams. And we convert our grams over here into kilograms. So we have 2 kilos of solution and we have 19.8 milligrams, and we simply divide the two, and there's your parts per million. So you need to be able to convert your units into milligrams into kilograms and then divide the two by each other to work out concentration in parts per million. If we were to work out concentration in milligrams per litre, that's again calculated by dividing milligrams per litre, which is equal to parts per million. So for example, let's take the concentration of 2 litres of sugar solution with 0.05 grams of sugar. So 0.05 grams of sugar is equal to 50 milligrams. So the concentration is therefore 250 divided by 2, which is 25 milligrams per litre, and that's actually parts per million, because 1 milligram divided by 1 litre is also the same as a milligram divided by a kilogram, if we're talking about water. Again, water has the value of 1 gram per mil. Therefore, 1 gram of water will equal 1 mil of water. So in this case, a milligram of water equals a millionth of a kilogram, because a litre is equal to 1 kilo of water, and a milligram is equal to 1 mil or 1 milligram of water. So percentage by mass. Well, this talks about the amount of solute in grams present in 100 grams of solution. So for example, let's take it, you go to the hospital and there's a 0.9% weight for weight saline solution. This is what they use to flush out wounds, as well as when you're on an IV drip. There's 0.9 weight for weight, or 0.9 grams of sodium chloride in 100 grams of solution. So over here, if you look closely on the bottle next time you see it, you can see it's 0.9% weight for weight. That just indicates, as I said, 0.9 grams of sodium chloride in 100 grams. If we had 9% weight for weight, obviously we'd have 9 grams per 100 grams. Percentage by volume, that talks about the amount of solvent dissolved in a solution. So we have alcohol, for example, has 14% alcohol in a glass of wine. That means there'll be 14% of ethanol, which is the active ingredient, by volume in 100 ml of wine. So here we've got a 200 ml glass of wine. They'll have 28 ml of alcohol if it's at 14% volume. That's obviously double. And the concentration in volume for volume is simply calculated by 28 divided by the total volume, or 200 mils, which gives you 14% volume for volume. So now you should be able to describe concentration using a diagram, and concentration is equal to the amount of solute in grams per litre of a solution. So we're going to divide and calculate concentration, and being able to calculate parts per million as well, knowing how to convert those two. Knowing also how to calculate and how to measure concentration as mass for mass or volume for volume. This is what you should be able to do. Determine the concentration using a diagram, calculate concentration in grams per litre, milligrams per litre, and parts per million, and calculate percentage by mass and by volume. These are the questions I'd like you to do. Thanks for watching.